Okay, so solving linear simultaneous equations. Absolutely tons of methods for doing this, but I tend to like thinking of it as these numbers in front of letters are called coefficients. So I want the coefficient of two equations to be identical so that we can eliminate one of the letters. Can't solve equations with two letters in them because there's an infinite number of solutions. So we need to eliminate one of these letters to end up with just so many x's equal a number. Then we can find out the x, or so many y's. Lots of ways of doing this. So I'm going to convert the x's into the same coefficient, but we could equally have done the y's. So if I want to turn the x's into the same, I'm going to make them both have 10x in front. I had to multiply the first one by 5 to do that. So that becomes 10x take away 15y equals 55. And I had to multiply the second one by 2 to do that. So that's 10x plus 4y equals 36. Now again, just remind, the reason we did that is because I can now do a calculation that involves making these x's disappear to 0. And that calculation is 10x's take away 10x's. So be really clear what you're doing. So we're doing 10x's take away 10x's, so that's gone. Here we've just got to be careful because we're doing negative 15 take away 4, which is actually negative 19y. And then we've got 55 take away 36, which is 19. So we divide by negative 19. So we end up with y is equal to negative 1. So really important we follow through with what we did. 10x's take away 10x is nothing. So that eliminated the x's, left us with just one variable y. Then we could solve for that value of y. Once we know the value of y, we can then use that value in one of the original equations to find the value of x. So we're going to use the top one. It didn't really matter which one. So 2x take away 3 times negative 1 equals 11. Notice I substitute by putting things in brackets all the time. So if I replace a letter with this value, I always put it in a bracket because it kind of helps me to think through, am I going to get things to cancel, change signs, do different things with it. So we end up with 2x's take away, well, 3 lots of negative 1 is negative 3. And then we've got to realise that 2x's take away 3 becomes 2x plus 3. And now we solve for x by taking away 3 from both sides. So 2x is worth 8, and then halving, so x is worth 4. So we think the answer is x is 4 and y is negative 1. But this is really important. We always check. So we go back to the other equation that we didn't use here. That allows us then to check that it works. So 5x, sorry, the other equation was 5x plus 2y. Now we want that answer to be 18, so let's have a look. So we've got 5 times 4 plus 2 times negative 1. 5 times 4 is 20. 2 times negative 1 is negative 2. 20 add negative 2 is the same as doing 20 take away 2, which is 18. So our check worked. So again, it's important that we do this checking to see what's going on. And again, when we're solving simultaneous equations, then it's always about making one of the letters have the same coefficient in front of it. And in this case, I made the x's become 10x's. I could have made the y's become 6y's, so I could have doubled the first equation and trebled the second one. Because I would have ended up with negative 6y and positive 6y, I would have ended up adding these equations at that stage to cancel the y's out to nothing. Different approach, but still would have given us 4 and negative 1. Okay, so solving linear simultaneous equations.